Thanks. Hello, everybody, and thanks to Maita, thanks Ajit, thanks Layla, and happy to be back here this year. I presented here at this session last year, and so much changed, and I'm very excited to talk about the connected world and how 5G makes an impact to that. Next chart, please. So if we look at what's happened over the last year, so this year we're going to hit 1 billion 5G subscriptions. So many things have changed, and we've been working a lot on the use cases that we talked about a year ago and made some significant progress. I'm going to cover some of those, and we'll be picking up on particular use cases in the next panel. So we at Ericsson have been working with a number of these use cases, and one such is the autonomous vehicle use case. And we worked with a company called Einride in terms of autonomous transportation. You see a picture here of a flatbed autonomous vehicle that can transport goods from port to road, and it is anticipated that something like 60% of transportation can be covered by autonomous vehicles like this. And this is a level 4 autonomous vehicle, not quite level 5, that's the ultimate, level 4, so we're definitely making progress. Next is the smart city case, and this is another Ericsson example of something called the Omniverse that we worked on with partners in Stockholm, Sweden, and this is a smart city digital twin. So imagine as a local government or a city being able to keep track of where are your vehicles, where are the nearest parking spots, and really all city operations can be controlled in this digital twin. If you're a sports fan, there's lots of things happening in the entertainment world. So this is an example that the Atlanta Braves have come up with a metaverse experience in their baseball arena. So you can go to the baseball arena, and then you can go to the metaverse and you can experience the game. You can even buy a foul ball baseball as an NFT. So kind of exciting there. Smart agriculture, for me, this is one of the most compelling use cases that we have to get right as a planet. And the UN have talked about 2 billion more mouths to feed in terms of human population. That would take 2 countries the size of India to be used as agricultural to feed those 2 billion people. So clearly we have to do agriculture in a better way, and smart agriculture is that way. Precision agriculture can give some significant benefits. And then the last on the right here, so healthcare. So if you're squeamish about getting your blood taken, you can now get a robot to take your blood. I'm not sure that's going to be a great experience, but that's something we can do in healthcare, and we'll talk about telemedicine. So these are some of the classes of use cases that have been worked on. Now, the big macro context for 5G and the growth up to 1 billion subscribers started in a number of phases. So first of all, building that coverage. So getting that 5G icon on your phone, typically low band coverage, getting that coverage out there. Next, we add in mid-band. So we add in mid-band that gives you that reliably few hundred megabits per second capability. Typically, a lot of 5G operators have added fixed wireless. So there's about 100 million fixed wireless connections globally. There's about 5 million or so in the US right now. That's growing very rapidly. And so that's another way of monetizing the 5G network. And then also in terms of commercialization, there's been lots of adjustments to premium price plans. So 5G's played a part in pushing people to higher price plans, and that's a way of operators monetizing and commercializing 5G. But for me, the biggest and most exciting area is around enterprise use cases. And the use cases are, we talked about some of them at enterprises. They are going from the lab to scale, right? And so to small scale trials, to larger scale trial, and we're on a journey there. And then that's generating lots of innovation. So some of the things I talked about, the platform of 5G is great for innovation, and we're really seeing that, and it's coming to fruition. And next chart, please. So this is really making a difference to economies. And here are some Accenture numbers that from last year. And normally numbers change radically here, but the numbers are in the trillions. And so if you look at all these enterprise and business segments generating sales from digitalization, 2.7 trillion. And then of that, 1.5 trillion falls to GDP benefit. So that's a massive impact on the economy here. And then 16 million jobs created or transformed. And again, these are the three kind of major use cases here. So manufacturing, $350 billion of sales, $159 billion of GDP, and 1.2 million jobs here in the US. Healthcare, big segment, 192 billion, and agriculture, 36 billion, but growing very rapidly. So we'll come back to these use cases in the panel. Next chart, please. And so if we take a deep dive into manufacturing. So in 2020, Ericsson broke ground on a factory in Louisville, Texas, close to where I live. And we've really been on a journey with the factory and delivering some of the planned optimizations and improvements. So for example, 50% reduction in unplanned downtime, 65% in manual material handled, and 25 use cases have been implemented. And that takes time. Hand in hand with that is the aspects of sustainability, and it needs a deliberate focus. So manufacturing is a particular segment that needs focus on sustainability. So our factory has 100% renewable energy powering it, 24% reduction in energy consumption. We have a water tank on the top of the roof that sort of saves 75% of the water usage. We have solar panels, and so the garage, you park under the garage, which has solar panels on, that's 17% savings on the solar panels. And we have now up to 200 robots running around the factory. It's kind of quite a sight. You see, it's very kind of futuristic if you go to the factory there. And that is a 65% reduction in the actual manual people moving physical equipment around, and a 5% better uptime. We use AR, VR, so XR, to do troubleshooting and repair. So as radios come off the line, you can look at them through AR and identify faults. And AI/ML to reduce inspection time, so it's fully automated. And it's been a journey, and we started out, essentially taking 5G modems and almost duct taping them onto devices, and now we're integrating that into the manufacturing ecosystem. So each of these use cases is a use case ecosystem. So expertise in the particular area, plus the chipsets and the modems, all contributing to the growth of these segments. And this has been successful. We've actually broken ground on the next phase of this factory. So a successful example, there's, I think, 11 million factories in the world, 300,000 in the US. So lots of scope for modernization around smart manufacturing. If we go to the next chart, please. If we look at healthcare, a Johns Hopkins study revealed that they saw a 30% cost saving from using telehealth, better patient outcomes, and a lot of out-of-network issues, especially in rural areas in the digital divide. You just can't go to an in-network doctor. That's a challenge. One of the big things is keeping people out of hospitals, believe it or not. And so there's 1.7 million infections and 100,000 deaths a year attributed to visiting hospitals. It's kind of scary. Obviously, lots of good things happen there as well. But if you don't have to go to the hospital, it's best not to. And so how are we achieving that? We're achieving that in telehealth through wearables. And so you can stay at home and have a heart rate monitor or a blood pressure monitor, a number of different wearables that allow the consultation with a doctor to be very effective. And so before, you'd have to come physically to the hospital to have those vitals taken. Now you can do it at home with wearables. And so that's a significant benefit of telehealth. And we have to do this because we see, studies show that in a few years' time, we're going to have a massive shortage of healthcare professionals, 145,000 people short. So if we can really automate the healthcare industry, that's going to give significant benefit to patients and the healthcare industry too. I talked about the precision agriculture and the compelling need to bring 5G technology to agriculture. If you look at the waste that we have in the system right now, so the farming process, 25% of food is wasted there, 50% of water we use for irrigation is wasted. And quite frankly, a robot can outperform human farmer significantly. Robots can spray 60 times faster than by hand. Drones can plant 100,000 seeds a day as opposed to 1,500 by hand. Collect lots of terrain data, soil samples, watering plans, and ability to harvest in a very effective way. So reducing wastage and making farming more effective, which is something we simply must do for the planet. Next chart, please. All of these use cases must be done with a backdrop of sustainability. And if you're not a believer in the importance of using technology to combat climate change, it's an absolute imperative. And so if we look at 19 out of the last 22 years have been record-breaking temperatures, 68% of major weather events caused by human intervention. And so these are really compelling things. And so we need to make sure that the temperature range, the 1.5 degree temperature range of the planet, is kept within. That's really important. So how does 5G help with that? So if you look at telecom networks in general, 1.4% of global energy is used in the telecom industry. And so you say, okay, that's not a massive amount, but the telecom industry could still do better. And so how do we do that? We need to make sure that the radios and the technology that we use in the networks are better than ever, more advanced. 5G inherently has a 40% energy per bit improvement over 4G. So simply flipping everything to 5G will provide a benefit. And then we need to do something that we call breaking the curve. So as data goes up, we don't want energy to go up with it. We want to get ahead of the energy curve by introducing new technology, more efficient radios, better spectral efficiency to be able to use less energy. But is perhaps the secondary or knock-on or the digitalization dividend energy that's even more significant. So studies have shown that other industries can benefit by 15% saving in their energy quotas by digitalizing. And so we see here, whether it's smart manufacturing or transport or avoiding to have to drive somewhere if you can do something by a digital approach, smart energy control of your houses, all of these things can contribute up to 15%. So there's both the direct impact of telecom networks and, more importantly, the indirect benefit that it's providing that will really help with sustainability. Everything we do has to be viewed by the lens or through the lens of sustainability. Next chart, please. And so more than ever, it's not technology that drives the next evolution. It's really technology's response to societal needs. And so if we look at some of the key trends in technology, so we say artificial intelligence, of course, we sort of throw that term at almost every problem now, but it's a very real benefit in telecoms networks. The mirror world is another way of talking about digital twins. And digital twin is a way of, whether it's your digital twin of a city or a manufacturing plant or whatever it is, or your house, you can provide a kind of time machine. And so you can go back in time and look at what's happened in the past and say, okay, why did this production problem or a traffic issue, why did that happen, and correct it. And you can roll forward into the future and look at how much extra production capacity do I need? How do I plan my city in a better way? So it's really a time machine. And so that digital twin will be an important aspect of future technology. Connectivity in everything is a phrase really that talks about as we move from millions of devices to billions of devices where we're at now to trillions of devices. So every inch effectively of the planet will be covered by sensors, and we can measure literally everything. And then we'll move beyond the smartphone. That will no longer be enough. We'll have XR capabilities, so virtual reality goggles, virtual reality contact lenses, and these will be the new devices of the future. And these technologies allow us to respond to some of society's needs. So we talked a lot about the very real climate crisis that we're in. These technologies will allow us to kind of help that. It will help us adjust to the post-pandemic society. So traffic patterns are totally different now. People are working from home. There are many different changes in society as a result of the pandemic, and technology needs to help us with that. As we become ever more dependent on our networks, it's no longer enough to say, oh, we just need secure networks. We need to redefine trust, because everything you do is in the network. And if you live in the metaverse, you need to know that what you're looking at in the metaverse is from the actual source, and there's no security issue as we go along with that. So trust needs to be redefined. And then all of this needs to be done in the light of global fragmentation. So it's important to keep global standards going, and it's important to manage the different geographic and geopolitical issues that are happening in the world. So technology and society coming together. Next chart, please. And then if we look at the timeline of 5G moving to 6G. So the 3GPP, Third Generation Partnership Project, has done a great job defining 5G. We're well through the process of 5G definition. We're actually now into a phase called 5G Advanced. And 5G Advanced brings in new IoT capabilities like RedCap, reduced capability devices. It brings in improvements in MIMO, multiple input, multiple output radios. It brings in improvements in how to handle XR data. So as we move into VR and AR, that is handled in a better way in telecom networks with 5G advanced capabilities. And then we look at 6G. So we see the rough time frame for 6G as standardization's roughly ready in 2028 time frame. And so we see 6G really happening in that kind of 2030 time frame. So there's a map here of from release 14 to release 21. So it's a kind of a regular cadence of releases with significant technology advancements along the way. And so we're heading into 5G Advanced, moving forward to 6G. So we have a little bit of time, but 2030 we see as the timeline for 6G. And then if you want to move to the next chart, please. And just to conclude then, so as we think about the real future, what's coming up, then we see the connectivity and connecting the world will be connecting the metaverse. And so 5G and subsequently 6G will be key fundamental foundations for the metaverse. And so here, a few examples here to talk about it. Here's an example in the bottom left, the metaverse city. So the mayor of Seoul actually came onto a metaverse as his avatar, and Oh-Si-hoon, his name is, and he said everything in Seoul, as from a government perspective, will be done in the metaverse. I can pay my taxes, do my government business, all from the metaverse. There's the metaverse hospital we talked about earlier. You don't have to go to a physical hospital. Concerts and entertainment. This is Ariana Grande, I think, but you can see BTS or Justin Bieber. You can go into the metaverse, see a concert. Tens of millions of dollars of revenue already generated by metaverse concerts. And then on the bottom right-hand side, we see the Metaverse Mall. There's a company that's worked 7 years on creating a 100 million square foot mall with 100 floors, compared to 3 million square feet is the biggest physical mall. And so you can go and transform commercial retail as well. But if you look at that from a network perspective, what is the expectation? The expectation is we have an acronym here called ROSI, which is resilient. So I need to make sure that my network is totally reliable because I'm totally dependent on it. So secure, reliable, enabling innovation. It has to be open. So I have to be able to interwork with different capabilities. Virtualize, so cloudification will be really important. Sustainability, we talked about the imperative for that. And then intelligence, again, everything will be controlled by AI because the complexity of these networks simply is so huge. And so we have to simplify through automation. So ROSI, resilient, open, sustainable intelligence, the way we see networks of the future. So I'll finish there. Hopefully that was a useful view of how the connected world is progressing and some of the significant steps that we've made in the last year and the long future that we have in the path from 5G to 5G Advanced to 6G. Thanks very much, and back to you, Leila.
Thank you very much, Paul, for this great keynote. My name is Izabela Gheorghisor, and I'm a Principal Communications Engineer at MITRE. A lot to think about from the slides that Paul just discussed. There are so many interesting points, just a couple that I kind of try to quickly take a note of. Paul showed the evolution of the 5G standards going from the early releases that build the foundation from 5G, now going to 5G Advanced, and the ability that will allow us to explore the more complex use cases, and then moving towards 6G by the end of the decade or so. The need for connectivity everywhere. This is, I think, an area that is being heard in many domains, and the the need to go beyond the smartphone, the move towards autonomous vehicles, the larger adoption of artificial intelligence, and the highlight of the networks that need to be resilient, open, sustainable, and intelligent. So a lot to think about. This presentation here is an introduction for our 3 panels this afternoon. And just a little bit about myself. My research interests are at an intersection of wireless technologies, aviation, communication simulations, and data analytics. And within OpenGen, my areas of focus are use cases, simulations, and developing future experiments for our 5G testbeds. So how can 5G help achieve this connected world faster? And we'll hear this afternoon about how 5G can help in 3 types of domains: smart agriculture, smart cities, and smart health. If we start with smart agriculture first, there are so many things that can be improved with the help of 5G connectivity. One can think of connecting soil sensors to 5G links and getting really real-time information about the status of the soil. We can think of situations where drones can be used to assess the development of crops, if we need to treat them at given times, and so on. We can think of use cases when actual robots, terrestrial robots, are used in smart agriculture, also to assess crops, to treat crops, and also to help with harvesting. So there are many ways in which 5G connectivity could help, and I am sure that the smart agriculture panel discussions will touch upon many of these and many other topics as well. If we think now of the smart cities, this is another such a broad and extremely diverse domain. I mean, we can think of just the connectivity needs for intelligent transportation systems, and that in itself is such a broad domain. The possibility of monitoring, for example, the electric grid, monitoring water quality, the ideas of smart buildings, street lighting management, and so many more. And again, I'm sure that the Smart City panel conversations will touch upon challenges and opportunities in this very vast area. And I think last but not least, of course, the smart health. And many areas there that could benefit from enhanced connectivity. I think all of us have had experience with telehealth calls, so common during the COVID-19 pandemic, and I'm sure that telehealth calls will continue. And the idea of more closely monitoring patients between their doctor's visits, and Paul touched upon that as well. The idea of exchanging data much more real time among multiple healthcare providers that are helping a patient at a given time to improve their care. One can also think further down the road on concepts such as connected ambulance concepts, and all the way to remote surgeries. So just staying within the kind of the healthcare domain for a moment, we can think that there are so many diverse use cases, and just here we can see that the connectivity needs for various use cases and various scenarios will vary also, and they become more and more stringent as we look towards the farther use cases. We can think of all these coming together in all three domains, we will see that they have specific use cases, specific needs, and those will translate into specific connectivity needs. So how do we enable this connected world faster? So I think that's a question that we are asking ourselves, and people are working on a lot. If we go back a little bit to some of Paul's main points, the idea of discontinued evolution, 5G with the foundation, the first foundational capabilities, then the continued evolution now into 5G advanced, and then going into 6G. So technology will continue to improve, and exploration of more and more complex use cases will be enabled, and the realization of those use cases. The need for connectivity everywhere in each one of these broad domains will be discussed this afternoon, I'm sure, in a lot of detail. The need for those networks to be resilient, open, sustainable, and intelligent so that they can support these very varied use cases. And the panels this afternoon will discuss three domains. More will be discussed tomorrow. Some have been discussed this morning as well. So we see that all these are coming together. And from our perspective, if we are thinking of, we need to understand what are the requirements in terms of the availability, reliability, latency, throughput requirements, so that all these various use cases that we are thinking of and they are coming into fruition are being developed with solutions that truly meet their needs. And we know that 5G deployments are ongoing and they will continue. We know that we need to address multiple use cases and have been thinking and discussing the various 5G capabilities that can help. And of course, from Open Generations, we are thinking of understanding also the early use cases for experimentation so that those can be experimented with in our 5G test beds. And so we are really excited to hear from our panelists this afternoon. And I would like to welcome Professor Guvench from the Department of Electrical and Computer Engineering at North Carolina State University, who is the moderator of our first panel on smart agriculture. Thank you.